My name's Katie Heatherly, and I'm here with Danielle Chappell, and we're both here from NSA, Cybersecurity Directorate. Our team does research in cloud and web technologies, and then we're here today to talk about some common Kubernetes attack vectors and then some mitigations on how to protect your clusters. So then just as our mandatory disclaimer, that we can't endorse any products that we are talking about. And then we also can't guarantee that if you implement everything that we say that your cluster is going to be 100% secure, because that's not really possible. So today we're going to talk about an overview of a Kubernetes cluster, some security features that are not necessarily built in, but are like in the open source community, and then some threat vectors and mitigations to the major components, which are the control plane, the worker nodes, and the pods. And then this year, we made an update to our Kubernetes hardening guidance, which we did some collaboration with some open source partner or Kubernetes partners to update that and to give an overview of some of the things that you can do to protect your cluster. So just so that everyone's on the same page on what a Kubernetes cluster is, there's a couple major components, or I guess first, Kubernetes is used to deploy, scale, and manage containerized applications. So you create containers, the containers are deployed into pods, and then the pods are what Kubernetes actually manages. So the major components are the control plane, which is the management and the control of the cluster. And then in the control plane is the API server, which is what actually sends out the management commands, the etcd data store, which holds the state information for the cluster, and then the scheduler, which load balances all of the pods onto the worker nodes. And then the worker nodes run the actual workloads and the pods, and then they communicate back to the control plane to make sure they're running the correct stuff. And then the pods are what holds the actual workloads that you're trying to run on a Kubernetes cluster. And then when you think of deployments, you're either going to be on-prem in your own data center or in the cloud, either running on VMs or in the cloud provider's service or Kubernetes service. Each one of those different deployments has a couple security advantages and disadvantages, so there are just certain things that you should be aware of for that. And then when we think of attack goals for Kubernetes clusters, we're usually thinking of someone trying to get access to data or hijacking resources for things like cryptocurrency mining.
So one of the things that your cluster administrator needs to set up when they first initialize a Kubernetes cluster is user authentication. There are several options for this, like OpenID Connect tokens, Bootstrap tokens, etc. But that does need set up when you first set up your cluster, and we strongly recommend using multi-factor authentication, especially for administrators. Service account tokens are auto-mounted to pods. We recommend using role-based access controls, setting that up to restrict access to pod secrets so that just anyone who has access to your pod doesn't have access to the secrets. So one of the most common authorization mechanisms used in Kubernetes is RBAC, it's role-based access control. To use RBAC, you establish privileges with roles and cluster roles, and then assign those to user groups with role bindings and cluster role bindings. So the example on the slide here is we've got this general cluster role on the left. It's just a pod reader role, gives access to get, watch, and list actions on pod resources. So then on the right, we are assigning that to a user in a namespace. So namespaces in Kubernetes clusters can be used to partition resources. So they don't provide any isolation themselves, but they can be used when assigning these authorization policies, and also when assigning network policies to isolate resources. So in this example here, we've got this role binding that takes the previous pod reader role and binds it to the user Jane in the default namespace.
So one other way you can protect the networking aspect of a cluster is networking policies. Networking policies are used to control the flow of data between pods. So a couple things to note about networking policies are that you need a container network interface plugin, and then network policies are used to allow traffic and not necessarily deny traffic. So the way you deny traffic is that you're creating these policies, and then any pod that isn't specifically selected in a policy does have all of its other traffic blocked. So on the left here, there's a network policy that selects the backend app and allows ingress traffic from the front end app. And then this would just be a typical networking policy, and then a mitigation to the thing that I mentioned about you have to select a pod for it to be isolated by default is a default deny policy, or something similar to a default deny policy. And this is just a generic, it selects all of the pods in the namespaces except for the management namespace. You want to be a little bit careful about that specific namespace. And then selects the ingress traffic. And you would also want to do this with the egress traffic if that was your goal as well. And then this satisfies the requirement of having to select all of your pods to isolate them beyond the network policies that you created.
So one other tool that you can use within Kubernetes to further secure it is the seccomp, secure compute tool. Secure compute performs system call, restriction, and logging, depending on your definition. So here we have an example policy that just has a default action to log all system calls, but we would recommend tailoring it to your containerized application to restrict all system calls that aren't used. That way, any attacker that gains execution in your container is limited in what they can do for post-exploitation activities. Then here on the bottom, I've got an example of a pod's security context where we've applied this audit policy, and now any container in the pod, any system call that is executed will be logged.
So now we're going to get into the specific aspects of a cluster. So starting off with the control plane, as I mentioned, this performs the management of the cluster. So some typical compromises that you would see with the control plane are if the control plane's left on the internet or some insecure network. That's been a pretty common source of compromise, even in the news. Unsecured communication, so encryption is something that you have to set up yourself. If you forget to do that, anyone can eavesdrop on your network. And then improper authentication and authorization. So the authentication and authorization can be a little bit complicated if you miss a step in locking down or using least privilege in your RBAC policies. Could allow more access than you're trying to. And then some security practices are implementing TLS encryption. This includes creating the TLS certificates, distributing those out to the different control planes and worker nodes, implementing strong authentication, as Danny mentioned earlier. Ideally, you want to have MFA. And then this would also include not using necessarily insecure methods such as like a password file. You want to disable all unused ports and network connections that aren't needed. So if you don't necessarily need access to the internet or to it could even be an internal network that you maybe don't necessarily need access to that. You can use some defense in depth to limit that access. Implement RBAC policies to restrict access. So you want to use least privilege when you're creating these RBAC policies to not allow too much privilege to any specific person. And then lastly, protecting the etcd data store with authentication. And then one way to do this could be using a separate TLS certificate and RBAC policies than you're using for the rest of your cluster. This would limit the damage. If somebody was able to get access to your TLS certificate they're using to encrypt the rest of the cluster, they at least wouldn't have access to your state information for your cluster.
So the Kube ABI server on the control plane handles all internal and external requests for the cluster. Each time it receives a request, that generates an audit event, and these audit events are all logged based on the audit policy. By default, there is no audit logging policy. That does vary for some Kubernetes as a service platforms, but for standard installations, there's no default. We do recommend creating one. There's an example here that we have on the slide that logs all requests involving secret resources at the metadata level in order to avoid logging base64 secrets, and then logs everything else at the request response level, which is the highest optional level. So this policy will log a lot of requests, so it may require tailoring for your environment depending on your capabilities for storage. However, if you're going to lower the amount that you're logging, you should keep in mind, like, the goal should be to reduce redundancy in your logs, make sure you're still logging all sensitive, security relevant requests. Some things that you can monitor your logs for are unusual API request patterns, large quantities of failed API requests, or requests from anonymous accounts.
So as I mentioned earlier, worker nodes are the nodes that actually run the containerized applications. So some common threat vectors that we think of when we're thinking of worker nodes are the kubeconfig files. These can contain sensitive information about the cluster or even allow authentication onto the cluster. So those files are stored on the worker nodes and possibly other VMs or computers that you'd want to keep in mind. Unencrypted communication, so you have to push out the TLS certificates to the worker nodes. If you forget to do that, you could leave some communication unencrypted. And then specific to worker nodes are resource exhaustion. If someone was able to create pods onto your worker nodes and then used a bunch of resources, this could cause some other pods and resources to not work. So some things that you want to implement to mitigate some of these risks are all of the same things that I mentioned for the control plane. Most of those are also going to apply to the worker nodes. And then some specific things to the worker nodes are keeping the nodes up to date, and this includes the virtualization software that you're using. So if a CVE or some type of 0-day, something like that came out for the virtualization software that you're using, you want to make sure that you're on top of those patches and you're not vulnerable to those if there's a patch out. And then lastly, network separation. So this can be not allow, or this can be not allowing access to internal networks that you don't need to allow access to. So you want to make sure that your worker nodes only have access to the resources that they need to have access to.
So as you're monitoring your logs, it's important to watch actively for indications of some of these attacks. That way you can stop them as soon as possible if someone is attacking your cluster. So one thing that's important to do is to continuously audit your pod deployments. Attackers will frequently deploy pods in your environment. This can be in order to increase their privileges, to run their own code or malware, or to create a backdoor. Sometimes they'll try to disguise these pods as part of your normal cluster by like copying naming conventions, especially of frequently used container names in your environment. One red flag you can watch for in your logs might be if, say, there was a pod deployment request where the source IP was a pod's IP, because a pod shouldn't be deploying any other pods, but say an attacker got execution in your pod, then that could be a red flag. You could also want to watch your logs for spikes in resource consumption, as that could be an indicator of a compute theft attack.
So the last major component that we're going to talk about is pods, which, as I mentioned earlier, hold the containers that are your actual application that you're trying to run and manage. There are several. These are some common pod threats vectors. There are obviously several more. I'm going to talk about a couple of them, and then Danny's going to talk about some mitigations and things to watch out for. One of the most common things that people are concerned about is container breakout. This could be due to a misconfiguration, so not forcing a container to run as non-root, something like that, or it could also be due to, unfortunately, something like a 0-day in your virtualization software, which isn't necessarily something that you're going to be able to actively protect against right now, but is something to be aware of and to watch out for. The second thing is supply chain threats. So when you're building containers, you're going to build containers either from scratch or you're going to build them on top of other containers. This could be like an operating system or an application or a database kind of thing. So you want to make sure that those other containers that you're building on top of also have good container security practices, because something like a secret in a different container is going to make your container also vulnerable to that hard-coded secret. And then the last thing I'm going to mention is the cloud metadata service. So this is when you're running things in the cloud, like VMs, for instance, the VM needs to be able to talk back to the cloud management. And this is going to be, it's going to have to query things about itself. So it's going to have to get its IP address and the network that it's running on, things like that. So those are things that if an attacker got control of your VM, they could also use that metadata service to query those informations. That could be things like the region, the network information, the image that you use to create that VM, SSH keys. And then they could also be used to get things even like credentials. So this is in all public cloud providers. It's not necessarily something that you can completely disable, but you can limit it. You can put authentication and authorization controls around it. You can specifically monitor for it. But it's something that is widely known, and it is a widely used attacker, or is something widely used by attackers. So you would just have to be aware of it.
So some things that you can do to harden your pods are running containers as non-root. This will prevent attackers from being able to exploit your container and get root context. It's also, you can monitor your logs for and configure it to alert when pods are deployed as root. File system access is also key to a lot of container breakout attacks. So when possible, it's good to use immutable file systems and also make sure you're not mounting host file systems to your pods or containers. You can also monitor for abnormal service account use patterns and try not to use default service accounts. If your pod needs a service account, create one specific to what privileges it needs. That way you don't have excessive privileged pods in your cluster. It's also good to consider implementing system call restriction and logging. This can be done using the seccomp tool that I mentioned earlier. And then it's especially important to make sure you secure your containers and applications that are running in the pod. Those are often the attacker's initial execution into your cluster. That's their initial point of access. So there's a lot that you can do with Kubernetes to identify and limit attacks and the effects of breaches, but it really a lot of times it's the application that they're attacking. So if that's not secure, they're going to keep getting in. It's also very important to aggregate your logs. A lot of times attackers, when they've gained execution in your cluster, they're going to try and delete logs in order to cover up their tracks and what they've been doing in your cluster. So you can aggregate them and pull them to a backend so that both in the event of a failure, because if a pod or a node fails, you could lose any logs stored locally, and then also if an attacker is in your cluster, they may delete them. So it's good to aggregate them from across your cluster, so logs will be collected at the application, container, pod, and node level. And logs don't really do much good unless they're actually being used for threat hunting. So it's important to collect those and actively scan them for threats. Some things that you can watch for when you're monitoring these logs, you can check for changes to pod deployments, and you can actively prevent with pod security admissions or alert on deployments that are attempted that don't follow established pod security standards. So this could be a pod running as root or a pod that's mounting the root directory. And then it's also important to monitor volume mount actions closely for abnormalities. And then you can also want to make sure that you're watching for alterations to pod deployments, modifications to RBAC resources, scheduled job creations, and edits to pod security admission policies. So attacks on Kubernetes clusters are being orchestrated successfully, and Kubernetes clusters are often very valuable targets, both for the data that they hold and for the compute resources that are often managed by them. So, and clusters are often not secure and open to attack. They're not secure by default. So it's important to be mindful of all of the features in Kubernetes and make sure that you're properly configuring it to secure your cluster. So the list on the slide is some of the things we've covered of ways to secure your cluster, and there's more details in our guidance that's posted on nsa.gov. Do you have any questions?
Thank you. Thank you. Great talk. The length of the list is a bit scary. So do you know if there's anything, and thanks for doing this stuff, but is there any sort of move in the Kubernetes community to move towards secure by default somehow? Because or have a mode where as a developer, sure, it's very cool that, you can just type things on your laptop and magic happens. But in deployment, you might want to have a different default setting. Is there any movement in the community to go in that direction that you guys are aware of?
Not necessarily that we're aware of, but some of these things are on purpose, so that you can plug whatever solution you want to use, and then some other things you can build in some like guardrails, like using things that like blanking on the name, but you can put something in place so that developers can only deploy a container that contains like these specific attributions to make them more secure.
I have been noticing some trends too. If you look at the changelogs, so like when we first wrote our guidance, anonymous requests were allowed by default, but then in like the next release they weren't. And like I've been noticing as I watch the changelogs, some things are improving. So
It's moving in our direction.
yeah.
You talk about the port security. There is basically it's using runtime, right? So you run container runtime to start your port containers. So have you considered using any secured runtime, like Kata, gvisor? They all secure the runtime, so put your container port in the sandbox so they cannot execute. Do you have this kind of practice?
Are you asking about things that will secure the run, or are there things that are moving towards securing the runtime?
Yeah, secure the runtime, like Kata, they based on KVM, and the gvisor, they are similar technology, so provide sandbox to run your order.
Oh, okay. Now, yeah. So we did come across these things. That is some feedback that we got when we did originally publish our first guidance. We added some guidance on securing the runtime in our Kubernetes hardening guidance. We did, as like people have mentioned before, there is a lot of stuff to secure, so we did have to draw the line kind of somewhere. We haven't specifically looked into those technologies, but we are aware that they are emerging things. That's it. Thank you for coming to listen. And that's all we have.